Hey guys, welcome back to another video. Today we're going to be talking about the Python package Numpy or Numpy. I tend to call it Numpy, but I've heard a lot of people call it Numpy. So it kind of is up to you on how you want to pronounce that. Some people may want to argue that in the comments, but I digress. So let's go ahead and get right into it. Numpy is a package that is actually used for doing vectorized math, like matrices math in particular. All of the arrays are vectorized, meaning that operations will be a lot faster. You have indexing and a lot of other things that just come along with NumPy arrays. There's a lot that I cannot cover in a video, just one video. So I think I'm going to do just functional things that you can do with Numpy arrays, like just creating them out of the box. And then we can talk about indexing into Numpy arrays, because that's its own video. Because you can do all sorts of stuff with indexing if you know what you're doing. So that's one of the cool things. This package is actually optimized by C code. In the back end of this project or this package is all C. So whenever you're running an operation with Numpy, you're running it with C code in mind. So you're getting the flexibility of Python with the speed of compiled code. So that's super nice. You're not going through the interpreter to do all these operations. You also have the ability to throw Numpy arrays on the GPU. So if you are ever in need of more raw power to do matrix-based operations, which is what the GPU is really good at, you can do that. You can throw it on the GPU. The GPU will give you that boost, especially if you're doing a lot of operations with Numpy. But that's just the beginning, and that's kind of an overview of what Numpy is. I will say this is a large package when it comes to popularity because of research opportunities. Not just research, but you can also do this. You can make essentially anything you want in regard to data storage. I've met some people that have generated like little games based off of Numpy arrays that they've kind of made. And it's really cool. You can do a lot of stuff with this library. But let's go ahead and just get started into how to use it. Creating Numpy arrays with values. So let's say you want to get started and you want to make a Numpy array. Well, this is going to be very specific. I have a data type, which is what dtype is. Well, first off, let's start here. We have an array, which is the variable name is ARR, which is kind of standard for some of their examples. But we have an array that is pulling from the Numpy package. We're creating a ND array. And then we're setting the shape to a 3x3. Whenever you're making a Numpy array, you are setting the shape permanently. Now, I put an asterisk next to that because you are not actually, you can extend the array and create new layers, but you're really just overwriting what that array was. It's not what's happening right out of the gate. There's some things going on behind the scenes. But you have your shape, and I've set it to 3x3, and I've set the data type to a numpy.int16. It starts to get a little complicated when you start running into data types, but we won't worry about that today. Now, if I go ahead and just execute this cell, it may say numpy is not defined because I need to run the imports. So if I run this, you're going to notice that I got random int16 values from this. So we just printed, you'll notice that it's just sending out random numbers. It's because there's no actual values that have been set in this Numpy array, and that's why we're just getting that. Otherwise, you would get a lot more from that. But I think if I also do this, I think it kind of does the same thing, yeah. just sends the same values. But you can see that we have a data type, and it just says array. And it's a 3 by 3, so we have 1, 2, 3, or 0, 1, 2, and 0, 1, 2. So you can kind of get the idea if you're familiar with Python indexing. You can index the same way. If you want to go to 0, 0, you just go to AR 0, 0 and whatnot. So that's our first for creating a Numpy array with some values. So it just kind of sets some values here. It doesn't really do anything. You have to overwrite the values and set them yourself. But what if you don't want to have these random values just scattered in your Numpy array? Well, what you can do is actually create a zeros array. So we are going to create an array again. We're going to pull from np.zeros. We're going to set the shape to 3 by 3 again. And I'm just going to set the data type to int16. You don't have to do that, but that's what I'm doing. And then we can print. And you'll notice we got all 0 values. And that is how you generate a 0 array. And that's probably what most people are going to want, is just an empty array. So let's say you just wanted to have 1 values in your array. Well, there's multiple ways to do this, but one of the things that you can do is actually just set the array from np.ones. So you have your array, and then you have numpy.ones, and you set your shape. And then you set your data type. You don't have to set the data type, but I did here. Very good practice to do so. And then you can print that. And now you have your ones all throughout your array. Really quick as an explanation, because I've had a viewer ask for this before, on why are some of these things good practice. If you ever run into a complex, if you're running into code and you start to have operations that are not giving the right values, there's a chance that the data type that you're dealing with is not specified and you actually need a certain type, which is a very particular issue that happens in model training. If you don't have the right data type, you're not going to get the right performance. Your model might freak out. There's a lot of things that could happen. All right, but here's the next section. We have our convert Python arrays to Numpy arrays. So I'm going to kind of explain this. Wait, what? Hold up. Not entirely sure why that appeared there. Oh, I see why. That should be np.int8. There we go. Yeah, there we go. Okay, cool. So whenever you have an array here, you have Python arrays to Numpy arrays. You have let's say we have a 1D array. So this is 1 dimension. And we just want to convert this Python list of numbers into an array, an NP array. And again, if you're more familiar, if you understand the differences between lists and arrays, you're going to understand why an array is going to be a lot more efficient time complexity wise. But we have this Python list that we want to convert to a Numpy array, so we can do Numpy options on it. So we have this array. We're going to run this, and we're going to actually set it to an int8. So you can set things to lower data types or higher data types if you want more precision. And then you can also do 2D arrays. So I have a list here with 2 lists inside of it. You can kind of see it here, but this is actually 2 lists, 1 and 2. And if we go ahead and run this, you'll notice that we have a 1D array right here. That's 1, 2, 3, 4, 5, and that's it printed out. And then you can also print in Jupyter notebooks this way, but you have 1, 2, 3, 4, 5, 6, and the D type is int8. So we were able to print out two different arrays. One was a 1D and one was a 2D. But let's say we wanted to do operations. So these are some simple operations. This isn't index related or whatnot. So we're just doing overall matrix math to our Numpy arrays. So right here we have an array1 variable, and it has np.ones. And if you remember, we have np.ones is going to give us an array of 1 values. So we should have a 3x3 of 1s, and then you have a +4 operation here. Well, if we're doing matrices math, what we should get is a 5 across the board. So if we run this, we got 5 across the board. Now, if we're subtracting from that array, and we're going to overwrite that array, what we should get is 4s if we subtract 1 from said array. And what do you know? We're getting all 4s. And let's say we wanted to actually multiply the arrays by 2. We wanted all the numbers in the array to total up to 8. So if we go ahead and run this, we get all 8s. And if we want to go back to 4s, we can divide by 2. And all it is you can do this pretty in a very simple way by just putting the variable and then dividing, subtracting, whatever you need to do depending on whatever the operation is. Well, let's say we also wanted to divide between 2 variables. So these are 2 arrays. If we wanted to go between 2 arrays, we have the array here I've created. It's from a .as array, which something to note, whenever I use np.asArray, asArray is turning a list, again, into a Numpy array, which is very different than our np. I think it's nd array. Yeah, this is very different. So you have to keep that in mind whenever you're converting an array or list-like item. So what we're doing is we're taking the np.asArray, and we take these items right here. So this is a 2, 4, 6, 8, 10, 12. And then we have a numpy.ones, and we're taking the shape from this guy. So this might seem a little complicated, but what we're doing is we're saying, okay, whatever the shape of this guy is, we want to generate a ones array that matches it. Because if you don't have one that matches, you're going to cause a lot of problems. They're not going to be able to do math between each other because the shapes aren't alike. You would have to, if you want to do it properly, set the shapes equal to each other, which is what I'm doing here, which is this array.shape. So we're setting the ones shape to said shape, and then we're adding 1 to it. And you may think, well, what does that do? So this is actually going to be a 2's array. So we have a 2's array, and then we have all these values. So if we're dividing by 2, what we should get once we run this cell is 1, 2, 3, 4, 5, 6. And that's what we should get if we're dividing by 2. So if we go ahead and run this, what we got was 1, 2, 3, 4, 5, 6. And that seems correct. So this is one video on Numpy basics. I have not went into the full-fledged thing. This is with the assumption that you guys know a little bit about lists in Python. If not, there's probably a video on the channel about it. And I'm willing to do a deeper dive into some more complex Numpy operations. But if you have any questions or want any particular function covered, let me know and I can make a video on that. Thank you so much for watching. Hope you enjoyed, and I will see you guys in the next video. See you later.